Hi, and welcome to Soil Science and Management, Chapter 9. Today we're going to be discussing drainage and irrigation. After we complete this chapter, you should be able to understand drainage and why drainage is important for soils. Be able to explain the difference between what a wetland is and what a wet soil is. How to utilize artificial drainage, different methods of irrigation, um, try to figure out how much to irrigate, and water quality uh, problems that you can face in irrigation. So in America, many of the land that we have suffers from some sort of moisture problem, whether it be too wet or too dry. Um, yeah, obviously here in California, we have a tendency to be drier in the soils just due to the um Mediterranean climate that we have here, and that Mediterranean climate allows rain um, typically in a glut one time per year, and the rest of the year is no rain. So that's what we deal with here locally. There are areas throughout the country where it is too wet or moist throughout the year, and this causes different problems such as anaerobic conditions, different microbial growths, um, and drainage issues are one of those things that have to be dealt with in these situations. So what is drainage? It's how rapidly extra water leaves the soil. So in previous chapters, we've talked about clay soils versus sandy soils. So drainage becomes important when we're just discussing those different types of soils. Obviously, those clay soils drain a lot slower than a sandy soil. Things that can bring about slower drainage are layers within the soil that will impede flow. So if there are any semi-impervious or impervious layers, they will not allow water to flow through, and this can then allow the drainage to become more of an issue in the upper layers of the soil. So what are things that contribute to soil wetness? Like I said before, natural impermeability. So these are these clay particles, or maybe there's rock formations that don't allow water to flow through. If you have excess flooding or water runoff that is greater than the percolation rate of the soil, you will have excess water in the soil or a high water table, and this is can be found in areas with rivers or lakes, or if you're closer to sea level, the water table can stay up high enough to the soil level where it's not allowed other water to flow away because it just continues to add on to the top of that high water table. So when we have this poor drainage, there are a few things that can happen. Number one, and probably the biggest issue, would be the lack of oxygen within the soil. If your soil is 100% saturated and the water is not able to drain out, the oxygen will also not be able to have a part in that soil. There will be no pore space for the oxygen, and this creates the anaerobic conditions that we really are trying to avoid at all costs. Very easy to see these anaerobic conditions. They are, you can smell them, you can see them, turns the soil black, usually leaves a sulfur type smell in the soil. Secondly, due to this lack of oxygen, poor plant growth is inevitable. If the plants can't breathe, then the plants can't grow, and it actually inhibits the amount of movement in the soil of nutrients. When we have excess water within the soil, it's very hard to operate machinery or tilling. Obviously, You've seen every kind of a piece of equipment get stuck if it's too moist, and this can be exacerbated by poor drainage or extra moisture within the soil. So wetlands are areas that are wet long enough and often enough to support vegetation adapted to saturated soils. So these would be, the common vernacular would be a swamp, and a wetland is typically a habitat for birds and different types of amphibians and reptiles, and obviously we have alligators that will live in these wetlands in Florida. You probably heard about the Everglades. Uh, this is a very large wetland area that has been protected to keep a natural wetland and allow those animals to live in a habitat. Some of the issues that you can have there are water quality, and this is due to, again, when you have a lack of oxygen within the soil, the water quality can be diminished by the microbial activity that is taking place within that soil. So often, if you have a true wetland, it is hard to utilize this for any other purpose besides a habitat or a recreational area. To drain a wetland takes considerable resources, and in this day and age probably would not receive the permitting required to drain many of the wetlands. We have some marshy wetlands in the Bay Delta area of California, and this is one of the most vibrant areas of California, and it's being currently restored to kind of the former glory in which it used to exist, and this is all part of many of the called Eco Restore projects that are happening within the state of California. So wet soils have fewer ecological functions than wetlands. These are more can be used more as farmland, and so about 25% of our farmland are these wet soils. The soils are wet most likely due to the climate in which the soils exist. Unfortunately, these soils have poor drainage and need to be need to utilize plants that don't mind growing in water. You can tell if a soil has poor drainage by the color. As I spoke earlier, it typically turns black because of the anaerobic condition within the soil. Different microbes within the soil will turn the soil different colors, and that will then permeate through the soil, leaving the black color. So there are things that can be done to utilize these wet soils, and that would be artificial drainage. So there are two main types. That's going to be your surface drainage, and that's going to be removing excess surface water. It's going to be canals or channels that direct water away from where you are trying to farm or work the land. The second would be subsurface drainage, and this is going to be pipes or other materials that collect the water within the soil and then don't allow the water to flow away. It will take the water as it's starting to drain, and will take this water to an area where you can put it into a canal or take it to another area where it has a better drainage. These underground pipes, if you're doing them in a landscape, many people have heard of French drains. These would be a perfect example of a subsurface drainage application, and they include rocks and certain types of pipes, and they are then accessed as the water drains out of the soil. So when we talk about drainage management, if we can add in these drainage tiles or drainage pipes, or utilize canals to increase drainage around a property, we can then increase the land productivity. We can use this land that may have been inaccessible previously for something that is, a benefit to the landowner, i.e., you can use it for farming, you can use it for cattle, you can use it for whatever it is that you decide that you want to do. When we look at landscape drainage, these are things that can be utilized throughout urban areas. This isn't super prevalent here in California, but there are certain areas, and I did mention the French drains. These can present themselves in areas of low-lying, or say a subdivision has a lower end, and all the water drains to that one lower end. These French drains or other drainage methods can be utilized to divert the water away from beneficial uses such as homes or whatever is in that area. So they can be used here in California, but this is more prevalent other areas of the country. So when we look at irrigation systems, this is the artificial application of water to a property for a beneficial use. This has been used in agriculture throughout the world for a long time. The Romans did it, the Greeks did it, I believe the Chinese did it, and what it does is brings water to an area where it's dry. The original irrigation systems were, a river that got diverted into canals, and then flood irrigation was utilized to irrigate land, or they built canals and aqueducts to move water over long distances to basically have these cities or civilization spring up in areas where it may not have done previously. Currently, there's several ways that water is applied: subsurface, surface. There's sprinklers. There's micro irrigation. There's drip irrigation. There's various different kinds of sprinklers. There's numerous different irrigation applications that are out there, and this is a big part of water or horticulture in California, because we don't have that natural flow. We don't have enough water that comes naturally in the summertime, and we have to supplement that. So subsurface irrigation is any application of watering in the soil, and as a matter of fact, I currently utilize subsurface irrigation in my home. I water my grass and a ground cover that I have in my front yard, all subsurfacely. The pipes are about 4 to 5 inches in the ground. They water once a week, and it's perfect because I don't ever have any runoff. I don't ever have any evaporation. All the water is applied directly to the root system of the plant, and I don't ever have any issues. Contrary to that is surface irrigation, and this is basically anything else that's not subsurface. The original the original surface irrigation was the flooding of farmland or other areas. This would have been the furrows, where you are sending water down a furrow, or there's also something called border strip, which is basically a levee system that is put around a farm, and the whole area is flooded to moisten the soil. So the furrows are the long strips, and the border strip would be the entire area is flooded. When we talk about sprinkler irrigation, a lot of these are agricultural specific and some of our older technology. So the hand move irrigation is basically exactly like it sounds. You walk over, you move the pipe with the sprinkler by hand to where you want it. There are solid set irrigation. This is typically what we would think about in our home. This is where it's set in one spot and it doesn't ever move. There's the traveling gun irrigation. This is a mechanism within the sprinkler that will slowly move a sprinkler throughout the agricultural field to allow it to not have to be moved by hand, and it will move itself. Center pivot irrigation is again exactly like it sounds. There is a center pipe that a series of sprinklers will pivot around, and these can be very large, very small. They can be half circles, they can be quarter circles, they can be full circles. However you utilize these center pivots, it's a very common modern way of applying water to an agricultural farm. And then wheel move is basically looks like a big wagon wheel is attached to a sprinkler pipe, and you have sprinklers that will move, and these are sort of hand moved again. They can be wheeled. There can be a motor that drives them. There's various applications for this. In a home or residential system, there are also regular sprinklers that would be called spray sprinklers or rotor sprinklers. These are utilized in your grass area, anywhere else. So in your landscape beds, for your shrubs, roses, garden boxes, you're going to use micro irrigation. So either a drip or drip tape, which is going to be your irrigation hoses. There's also micro spray irrigation. This is going to be small spray sprinklers that apply limited amounts of water in a misting formation. Hard to use sometimes in California due to the wind we have here. But in your landscape, you typically utilize more than one type of irrigation system. So you'll have sprinklers, you'll have micro irrigation, you'll have drip irrigation, you'll have various different types. So basically, the ideal use of irrigation is to bring your root zone to field capacity, allowing that root of that plant to drink the water. You don't want to irrigate every day if you don't need to. And 50% of the soil has been drained and is not utilizing the water, then you're going to reapply. So you don't apply until you have until your plants have utilized 50% of the water that's been applied and is available, and then you are going to reapply. So that's how you decide when to irrigate, is when you get to this 50% level and you are going to use your ET or evapotranspiration rates to determine this. So typically in California, in the hot of the summer, your plants are losing between 0.3 and 0.5 inches of water per day. And this is the amount of water that you're going to need to put back into the soil to allow those plants to remain healthy. So there are several ways to know how much irrigation to use. You can touch the soil, feel it. You're going to know how moist it is by touching it. You can use potentiometers. You can use evaporation pans. Probably the most common thing that we do nowadays is utilize irrigation controllers to time these various applications, and smart controllers are now something that can be utilized to determine how much water to be applied. This is going to be utilizing your evapotranspiration rate again, and the irrigation controller will then calculate how much water to be applied every day, allowing that amount of water to be only the amount of water that's lost to those plants, as opposed to watering the same amount every day. Because if we're watering the same amount every day, then we're wasting water. We're not becoming as efficient as possible. So how much do we water? This is all dictated based on what kind of type of soil, how deep your roots are, what type of plants, what is your climate. There's various things that you need to take into consideration when we determine how much to water. And then your application rate, this depends on what type of soil and how quickly that water will infiltrate. So soil versus clay, and then how we're going to apply that water. So when we are saving water, we want to use the most efficient water system possible. We don't want to water before we need to, only using the correct amount of water. If we're having shrubs, we don't want to use spray irrigation on those. We want to use drip irrigation. Where if we have grass, we don't want to use drip irrigation. We would like to use spray irrigation. So the correct application of water to the correct product is very important to understand. So when we think about our irrigation or our water, we have to think about our water quality. There are many things that can be a detriment to our water quality that will allow that water to hurt our plants. So certain things like suspended solids, these can be an issue because they can clog your irrigation. They can be dirts, sands, they can be chemicals, various things. And then your soluble salts are probably your biggest thing that you need to worry about. And so you've probably heard of something called TDS. This is your total dissolved solids. That is your soluble salts. And when you increase the TDS level to a certain point, the water is not able to be a benefit to the plant. And it actually is a detriment. And the plant is kind of like us. If we are drinking salt water, it's not healthy for us. We want to make sure that we're drinking only fresh water. Well, same goes for plants. It doesn't like to drink the salt water. It wants to drink fresh water. Something we can do to combat these TDS levels that accumulate within the soil is leaching. This is applying an extra amount of water to push those salts through the root zone of the plant into a lower soil layer. So just to think about what soil moisture conditions are during the growing season, these are some terminologies that you can be used. So there's xeric, which is equaling to dry, mesic, which is kind of your middle or average, and then hydric, which is wet. And you can think about that, everybody has heard about like hydrophobia. That's the being scared of water. Well, when you start to see that HYD at the beginning of something, it typically has to do with water. So there are actually applications where you are going to use these terminologies in the soil. So I just mentioned hydrophobic, and there can be times when your soil becomes hydrophobic and there's almost a coating, a wax-like coating over the soil, and the soil will actually repel the water away from it. So you just, I guess, more of a language terminology lesson there, understanding these acronyms. Another one that is important to understand with xeric is some people have heard of xeriscaping, and this is when you are using a low water using irrigation or low water using plants. You call it xeriscaping. So another example. So that's the end of this chapter. In summary, I hope you kind of understand what artificial drainage is and why we use that, different types of drainage systems, and then different drainage versus irrigation usages. Now, something I didn't really mention is you actually at times will have a drainage system and an irrigation system that are used in conjunction. So you still have to get water to the plants, but at times that water can be held in areas where the plants don't like it, and that's when you have to utilize the drainage system. So I thank you. I hope this lesson was good, and we'll see you next.